Again, this is the review for your circles test. I'm going to do the evens. You're going to do the odds. So going over the evens, this is for the whole unit, one for all of it. So going over the evens, we have the area equation. Your area equation. You can use your notes. I'm not asking you to memorize this.
Yeah.
So make sure you have it written down on your notes or at least on this worksheet. Area equals pi r squared. Here is our radius of 2. So I plug it in.
A equals 2. No.
Radius equals 2. We're solving for the area.
All right, so R
Is 2.
So do we like multiply?
Yeah.
That's
Plug
4.
that in the calculator. 2 squared is 4. If you don't have your calculator, you need it.
Give me mine. I don't even
So
know.
I'm going to put,
I don't know.
it says to use pi. So I'm actually going to hit the pi button.
This is
Rhodes?
This is Rhodes.
Yeah.
What number am I on the calculator?
It's on the sheet. Well, I think it's moved actually. On this one, I'm rounding to the nearest whole number. So my nearest whole number is 13. So this was 12.5. So my area equals 13 yards squared. Area is squared. Area is squared. Number 4, we're also finding the area, but we're given a different measurement. D equals, what's D stand for? Diameter. So if your diameter is 14, how do you find your radius? Divided by 2. Remember, your radius is half of your diameter. So if the whole thing's 14, your radius is 7. So from here to here is 7. And then we plug that into the equation just like we did. Equals pi r squared. And plug that into the calculator. $49 times. The pi button is down in the letters. The pi button is down in the letters. You need to know that. And that one I'm rounding
To the nearest whole.
10th. And the directions it says the nearest 10th. So that's the one after the decimal place.
So it's 154.
That's whole number.
Oh, 153.9. No.
Yes.
150.
Yes. 1 5.
You're rounding to the 10, so you move your dot 1.
Oh. Okay.
Area equals 153.9. I'm going to see what it was. 38. All right, remember with rounding, 10th place is the first one after the decimal. So you look at the 3. The 3 is too small, so it's going to stay a 9. Again, feet squared. Area is squared. On your test, if you know area is squared, you probably can eliminate some of your answer choices. For 6, you need to know your circumference equation. So your circumference equals, it's either 2 pi r. So if you're given the radius, I'd use this equation. Or your circumference equals pi times your diameter. Either of those work. So on 6, is 4.3 my radius or my diameter?
Your radius.
My radius. So I'm going to use this first equation. So my circumference equals 2 pi my radius. And anytime I plug something in, I use parentheses. 2 pi, 2 pi, 4.3. It says round to the nearest tenth. So is it going to stay at 0 or go up to a 1? Stay at 0. So 27.0. And circumference is just inches. Area is squared because it's length times width. Area squared, length times width. Circumference is just walking around the building. So if I was walking around this building, it's just inches or how many feet I walked around. If I was doing the area of the building, I'd have to multiply the length times the width of it. So that's why area has a squared on it and circumference does not. All right, on 8, we're given the diameter. Given the diameter, so I'd use the other equation. C equals pi times d. So C equals pi times 20. So 20 times pi. 20 times pi. And if your calculator is not giving you a decimal, remember you have to just hit Control Enter to get your decimal.
It's 62.8.
62.8.
It's gonna go up to 62.9. Oh, no, 8.
Stays 8. You already rounded. And again, circumference is just the single unit, meters.
Excuse me.
All right, number 10 is definitely the hardest because it doesn't give you the radius or the diameter. It gives you the area. So going to the area equation,
So how does area work?
area equals pi r squared. That's the equation for area. Area equals pi r squared. We know our area is 12.6. So I plug that in for A. And now I have to solve for my radius. I have to solve this for my radius. This is an equation. I have to solve for my radius. Divide it by pi. And that'll give me r squared. And I'll put that in a calculator. 12.6 divided by pi.
So we're gonna stay at
And it says we can round to the nearest tenth. So 4.0.
4.0.
So 4. So our radius squared is 4. To get rid of squared, you take the square root. From algebra 1, to get rid of squared, you take the square root. Yeah, nice. The square root of 4 is 2. If you don't know that, you need to know the square root button is Control, your yellow button, and then x squared.
X squared?
Yeah, so that's where your square root button is. Control x squared gives you that square root button. So the radius is 4, which is great, but that's not what it asked. We're asked for the circumference. So now I'm going back up to my circumference equation. So now that I know my radius, I can plug it in. And you can put all that in a calculator. Or you can put 4 pi in a calculator and get an answer.
Man, somebody saw pi like every number in there. How many numbers in that?
Pi, infinity, they'd still be working on it.
So nobody knows the ending of it?
I know it's 3.5.
Then you would know the end of it if it was like that.
It's 5.
So 12.5 or 12.6. 12.6
I know that
centimeters.
there's some kid, but not from the school that knows the whole entire.
All right. I'm going to pause now and walk around while you guys work the odds. The second page. Find the measure of the arc or central angle indicated, assume that the line which appears is the diameter are actual diameters. So I'm telling you these are diameters. So I'm doing the evens, you're doing the odds. We have to find EDF, angle, EDF. That's what we're trying to find. So if EG is the diameter, that means it cuts your circle exactly in half. So what's the degree of a circle? So 360. 360 degrees equals a circle. So what's half of that? 180. So a semicircle, half of it, equals 180. So this diameter is saying this whole side equals 180. So from E all the way to G, EFG is 180. So our arc is 180. We know this is 40. How can I figure out what's left? EF. Subtract from 180. It's 140. So arc E to F is 140. What does that make the angle, a central angle? So the angle, the measure of angle EDF equals, if this arc is 140, what's the angle? 140. Yeah, they're equal. The arc is equal to this angle. So if this is 40, this is 40 degrees. If this is 140 degrees, this is 140 degrees. That's called a central angle, because central means the center. So your angle is coming from the center of your circle. So your angle is coming from the center of your circle. They're equal. The angle is equal to 140. So 140. Find the measure of arc DEC. DEC is a major arc. Major arc because it's over 180. We know this is 45. Can I figure out what BE is? Subtract it from 180. $135. Because BE and ED have to add up to 180. How? All right, these angles are vertical. So this angle equals this angle. So if this is 45 degrees, that's 45 degrees, that's 45 degrees, this 45 degrees, a lot of 45 degrees in this circle.
And is it the 135 and then the other side also 135?
So if this is 135, this is also 135. And then if you want to check to make sure you do it right, you could add all of them to make sure it equaled 360. But we're trying to find D, E to C. D, E to C.
So you add up 45 plus 45 plus 35.
45 plus 45 plus 135. Yes. So 45
That's 90.
plus 135 plus 45.
225.
225. All right. So if this is 45, BD is your diameter, so you know that has to equal 180. So if this is 45, 180 minus 45 gives you 135. If this is 45, a vertical angle is equal, so this is also 45. And then you added them together. 45 plus 135 plus 45 gave me 225. Okay, 16. Solve for x. Assume the line that appears is the actual diameter. Okay. Solve for x. So here is x. X is talking about this angle right here. Do you agree? Okay. We know nothing about that angle. But we know all of the angles added together equals 360. What's this angle? 90. Nice. So we all agree with that being 90. So if I add all of these angles up, it's going to equal 360 degrees. So I'm going to write that all up. So
325.
that one plus 45 plus this one plus 65 plus 90 plus 125 equals 360. Ran out of room. I can't do anything with my x because it's the only x. And then all of these other numbers I can add together.
330.
330. Do we believe him?
Yeah.
Yes.
I did all of that.
I do.
Nice. Equals 360. So 5 plus 45 plus 65 plus 90 plus 125 equals 330. And then it's a two-step equation.
What?
Now we're at a two-step equation. We're trying to get x alone. So you want to add or subtract first?
Subtract.
Subtract. Anytime you go over your equal sign, you do the opposite.
Equals 30.
Equals 30.
And then divide
Divide by negative 3.
x equals -10.
X equals negative 10. You want to check your answer, you can plug in negative 10 here and make sure they all add up to 360.
Let's find it up with this week. Let's find it up with this week. Yeah. Right.
18 is the same, but now it's instead of the internal angles, we're talking about the arc lengths, but they still add up to 360. So I'm add all of this up and set it equal to 360. So 125 plus 35 plus 45 plus 66 plus x plus 95 equals 360. $366. 125 plus 34 plus 45 plus 66 plus 95
Equals 366.
Yeah, 366.
Nice. 366. Literally just putting them in the calculator. Solving for x, I subtract 366.
-6.
Negative 6.
Okay.
Before I come around and make sure we're doing the odds right, I did want to talk about 15 because 15 doesn't look like these two or these three. How would you set up an equation to solve for x on 15? We know that's 90, but we don't know anything about these two angles.
So wouldn't it be technically 9x plus 13 equals 110? No, is it 90? I forgot. Wait. Let me think. I know it's 9x
The
plus 3.
Arc,
3.
the arc equals 85. A central angle is equal to the arc length, arc measure. A central angle is equal to the arc measure. So you just set those equal and solve. All right, I'm going to pause and let you guys work the odds, and I'll come check them.
I'm gonna talk.
The third page, we're finding the length of each arc. So the arc length formula, length equals x, where x is the degree measure of the arc. C is the circumference, divide by 360. So our length
Am I right?
equals x, the degree of the arc.
I want to see Tyler.
So our degree is 45 times my circumference. Our radius is 11.
Oh,
So we have to plug it into our circumference equation.
22.
So 2 pi 11 divided by 360.
Oh, I remember this.
Mhm.
But you need wipes.
And I just plug all that into the calculator at once. If you do it in sections, you're more likely to mess up.
You should have. You had some last time.
Kleenex, I have tissues. Unless they used them all. Unless they used them all when it's fun. So I did,
My bad.
where'd it go? 45 times 2 times,
That's 8.6393798.
I didn't got that.
I think
Because I did the whole thing.
Oh.
8.63.
Dang it. I messed it up.
And it says round to the nearest tenth. So 8.6.
8.6.
That's the final answer.
That's easy.
And this is a length, so it's just centimeters. Yeah. As long as you have the equation written down, I don't see how you can have too much trouble with that.
They went through my paper.
Oh, yeah. Oh, my God. 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 Water through paper. Oh, my God. That is so crazy.
So here's area of a sector. Your area equals N, which is the arc length right here. So from here all the way around to here. Yep. Here's your formula. N over 360 times pi r squared. So this is a central angle. So if this is 315, the whole arc is also 315. Area equals 315 divided by 360 times pi r is 10 and squared. Again, I plug it all in the calculator at once so you're less likely to mess up. So 315, if the central angle is 315, the outside arc is 315, and you're just plugging it into this equation. Write this equation down so you can use this on your test. 315 divided by 360 times pi r squared. Our r is 10. I plugged in 10, and then I put it all in the calculator at once so I didn't mess it up. If you do it in sections, you're going to have rounding errors. Do it all at once. Find the measure of the arc or indicated angle. So now we're on something called inscribed angles. Anybody know what inscribed means?
Nope.
That means it's on the circle. Your angle is touching your circle. Inscribed. Angle touching the circle. The other angles we were working were central angles. Your angle is touching the center of your circle. Here, inscribed, it is touching the circle itself, or angle is touching the circle. So here, angle T is what we're trying to find. If you are given the arc that angle opens up to, this is kind of a hard visual to see. your angle, 1/2 of your angle equals your arc. For inscribed angles, 1/2 of your angle equals your arc. If you're given the arc, then you can do 2 times your angle. If you are looking at this angle, which we are, I'm going to extend it just a little bit to help see. We're given the arc. That's this arc symbol. We know the arc is 124. Wait, I have this equation flipped. My bad.
What?
I have it flipped.
Dang.
The angle equals 1/2 the arc, or the arc equals 2 times your angle. I always have to think about it. So we are given the arc. So to find my angle equals 1/2 my arc. So my angle equals 1/2. The arc is 124. So what's half of 124?
It's half of 124.
62.
64.
62 degrees. So if you're given the arc, take half of it to find your angle. If you're given the angle, double it to find the arc. So now we're given the angle. I'm going to extend it, our angle. And we're looking for the arc. We're looking for this arc. The arc equals 2 times my angle. So that arc equals 2 times 53.
I'm getting confused here.
106. All right, I'm going to pause it and you're going to do the odds. We didn't make it through all of the packets, so your test is on Wednesday, and your homework is to finish the whole thing through 26. I did the evens with you, but if you didn't copy them down, you got to go back and do them. So finish that whole packet all the way up to 26.